The Scandinavian cut-to-length or short-wood system is efficient, gentle on the environment, ergonomic, and economical. It's taken many years of hard and purposeful work to develop the system to the qualities it offers today. "60 years ago, all forestry work was done by hand. Trees were felled by means of two-man or one-man crosscut saws or bow saws. Limbing was done by axe. A barking spud was used for barking. The tool slid freely along the log in summer, but in winter, when the bark was frozen, it was hard and laborious work. Extraction was done by horse, of course, and almost only during the winter, when the snow and ice on the ground made the going easier. After the Second World War, the two-man chainsaw became available. These saws weighed more than 20 kilograms and were mainly used for cutting the largest trees. In the early 1950s, power saws weighed only 15 kilograms and could be handled by one man. This saw was made by Jobu, a well-known name in those days. Before the saw could be used for bucking, the carburetor had to be repositioned. But the biggest advance in logging during the 1950s was made at the truck road. In 1955, Brundell and Johnson presented their cambio barking machine. Very soon, manual barking became a thing of the past, and at a stroke, logging productivity was doubled. By the early 1960s, chainsaws had become so lightweight that they started to replace the axe in limbing. Initially, neither the saws, the methods, nor the safety equipment were suitable for this work. Accidents were commonplace, and many cutters suffered white finger syndrome caused by vibration. To avoid cutters having to come back to buck the stems after the foreman had measured and marked out the bucking points, the cutters themselves were made responsible for this work. A special measuring tape was designed to enable the cutter to measure the length whilst limbing. Similar measuring tapes are still in use, but today's cutters are kitted out from head to toe with safety equipment and clothing. Chainsaws and working technique have also been improved for greater efficiency and enhanced safety. Studies carried out in the 1940s established that improvement of the main haul roads was vital. A variety of ploughs were developed and subjected to trials. With the use of a trail grader and assisted by water and icy weather, slippery tracks were made in the haul road, enabling a single horse to pull an enormous load. As the network of truck roads was extended, logging could take place in the snow-free season as well. The traditional log sleds were therefore modified for this purpose. For instance, drays equipped with both wheels and runners were produced. In the early 50s, a variety of trailers for extracting roundwood were produced. Most popular was this one, named Fussingen. In the early post-war years, many motor vehicles became available for civil use. Naturally, these were primarily used in extraction work. This one is a Munktel wheeled tractor. Crawler tractors were even more commonplace. This one is an Alice Chalmers. Attempts were also made to use small crawler tractors, like this Kletrak Oliver HG, in the stands themselves, but loading took far too long. So, which type of tractor would prevail? The experts and the machines were brought together for comparative trials. The test run was treacherous. This rigid full-track vehicle failed to surmount the obstacles. But well-known machine manufacturer Martin Östberg negotiated the obstacles with ease on his flexible full track. Down south, They were more interested in using farm tractors for forestry work, and the popular Ferguson MF35 was put through its paces. But unfortunately its grip was just not up to the task, as the onlooking band of smart, besuited delegates could bear witness to. Upending was another problem. In an emergency, this was remedied by piling extra weight onto the front. So farm tractors didn't really become useful in forestry until the semi-tracked machines appeared in 1952. The technique of compacting snow was refined on the long extraction roads up in the north. First, a crawler tractor was used to make ruts in the snow. After a few days in freezing temperatures, the road could be leveled off. A well-made and well-maintained road of compacted snow could remain passable well into the spring thaw. Such roads could carry enormous loads as well. This load consists of nearly 40 cubic meters of timber. To get maximum usage out of the tractors, the trailers were loaded by a separate team. The strenuous job of loading by hand was made easier by a side loader, which could also be used to move the trailers over short distances. 1957 saw the appearance of the first specialized forestry machine, the BM Bamse. This was purpose-built to provide good off-road mobility. It was also equipped with a wire crane which, with the assistance of a nimble helper, meant that the machine could be loaded quickly. The Bamse was a flexible, full track with brake and clutch steering. The first hydraulic grapple loaders became available in the mid-1950s. In those days, this was thought to be a comfortable working position. In 1962, BM Volvo unveiled the Nallen, which was to become the next big-selling forestry machine. The Nallen was a three-quarter track machine with hydraulic frame steering. A year later, VSA introduced the Brunette wheeled forwarder, which had frame steering and hydraulic drive to the rear wheels. The base machine was a BM Boxer with the front wheels removed. The SMV Drivax appeared a few years later. This forwarder had bogies on the trailer section. When required, the bogie wheels could be driven by a drive roller. The Hemek Aldrive went one step further with its 8-driven wheels. The forwarders produced during the 1970s were close to the definitive design. This is a Kokum KL875 with an oscillating axle. And this, a BM Volvo SM868 with a trunnion tube. The Ursa 260 was the first forwarder to have hydrostatic transmission. Small, nimble forwarders like this Brunette were built for work in thinnings. Today's forwarders come in a host of makes and sizes. The Rotner G has a payload capacity of 8 to 10 tons and a steerable bogie for greater control. The 6-wheel Valmet 890 can carry a payload of 16 tons, while the 8-wheel version has a payload capacity of 18 tons. To demonstrate that felling and limbing work could also be mechanized, a Beloit tree harvester was imported to Sweden in 1965. Although the machine wasn't suitable for use in Swedish forestry conditions, it inspired the designers towards further mechanization. 1967 saw the launch of the first Swedish-built limber, the Logma. The limbing technique was really the same as that used on the Beloit tree harvester, except that the Logma processed the trees horizontally. Because delimbing of the trees started from the top, it was possible to achieve suitable concentration of the timber in the felling operation. Ursa presented an interesting solution for bucking the stems, consisting of a boom-mounted grapple saw, a technique that would surface again later. In 1966, the VSA processor was unveiled in a field in central Sweden. Limbing was effected by means of rotary flails. Kokum took over the idea and marketed the machine as the Kokum Brunette processor. The operating principle proved to be successful, and other manufacturers soon adopted the concept. Here we see a BM Volvo SM880 at work. Major efforts were made towards the end of the 1970s to design nimbler limber buckers. The Rottner processor was equipped with rubber feed wheels to avoid the damage caused by studs. The Kokum Bootsmarkan was an even smaller machine and had the processing unit mounted on a slewing arm. With the introduction of these two limber buckers, the mechanization of thinning could now get properly underway. But more on that later. In the limber bucker systems used in final fellings, work on mechanization of the felling operation started in the early 1970s. A chain saw was used on the Ursa 670 feller buncher. The Kokum 880 feller buncher was equipped with hydraulic shears with spherical knives to minimize damage to the stem. 1973 saw the introduction of the first true harvester, the Ursa 710. All the functions, that is, felling, limbing and bucking, could now be done by a single machine. One operator controlled the felling and another the processing. The first harvester was not alone for long. Many successors were hot on its heels. One was this Volvo BM 900 harvester, which was launched at the end of the 70s. Since the end of the 1980s, harvesters have been used in nearly all final felling operations. The so-called two-grip harvesters now operate only in stands with the largest dimension trees. This Rottner two-grip harvester has a parallel action boom and can fell trees up to 70 centimeters in diameter. Maximizing the value of the timber is vital. The operator therefore has access to a merchandising computer, which helps him to decide the best bucking points along the stem. High energy prices in 1980 focused interest on utilizing logging residue as fuel wood. Brooks produced this chip harvester, which reduced the residue into hog fuel. One problem with handling wood chips is the low density of the load, which makes haulage costly. Systems have now been developed that compact the logging residue into bales known as composite residue logs. The FiberPack 370 produces bales that are 3 meters long and weigh about 500 kilograms. These are handled in the same way as conventional roundwood. Let's now return to thinning and look at the various steps taken to mechanize the work. First out was the Levab G1, a harvester that worked on the strip road. A boom with a 10-meter reach was used for felling, and the processing was done in the strip road. Just 2 prototypes were made of this machine. Husqvarna mounted a French-made limber bucker head on a forwarder, thus creating a multi-function machine. The same principle of using a compact processing head was adopted by the Skogsjan. Here the head was mounted on the end of the boom. This machine proved to be highly efficient and inspired other manufacturers. The next step was to incorporate the felling function. This resulted in the single-grip harvester and efficient units for mechanization, such as the Ursa Eva and the Valmet 901 seen here. There are numerous makes and sizes of single-grip harvesters for thinning on the market today. This, the Grimo 950 with a parallel action boom. The improved performance of the single-grip harvester now makes it the dominant machine used in final fellings. This is the Caterpillar 580, which can fell trees up to 65 centimeters in diameter. It has wheels and the bogies on swing arms to keep the machine level. A clear trend in the development of logging machines has been the wish for each unit to perform multiple functions. And today we can already see the next step forward, the Harwarder. This machine is both a harvester and a forwarder. During processing, the timber falls straight onto the swinging bunk for subsequent extraction to the truck road. Thanks to determined work over the years, we have developed logging systems that meet today's exacting requirements. But the bar is constantly being raised, and the development work continues, with close collaboration between the manufacturers, the users, and the researchers. We are therefore confident that Swedish forestry will maintain its leading position in the field of technology as well.